Hi friends, MoNaCo here. We are in our fifth video of our moles and stoichiometry unit. We're talking about types of chemical reactions today. And while there's millions of different types of chemical reactions out there, we're going to only focus on the four most basic ones for this portion of our chemistry this year. So our lead-in, we can build chemical equations. What makes one chemical equation different from another? So a chemical equation is, before and after the reactants and the products. There's four basic forms that we're going to be talking about here. And they're all straightforward. So in the type 1, we got single replacement reactions. These types of reactions are where one species, and I mean species, I mean compound or element, replaces another one in a reaction. So from examples you can see here, we have Ag and AuCl3. So in this example, we have Ag replacing the Au in that compound. So Ag is essentially coming in and kicking out the Au and saying, hey, it's my spot. So it's a single replacement. Typically, these follow the format of this type of equation. If we have species A, which is an element by itself, and you add a species BC, which is a compound, you will have a single replacement come in. The A comes in and replaces the B. So we get AC plus B. So a single element comes in and replaces an element that's in a compound, and that one gets kicked out. Alrighty. So the second type of reaction that we got to talk about is a double replacement. So if a single replacement was one guy coming in, and a double is like a double swap. So for example, we have things like this. And these often contain polyatomic ions, so be wary and looking for them in the shields there inside the parentheses. We have Pb, NO3, and NaCl. And as you can see, the Pb and the Na swap because now it's PbCl and NaNO3. So we have a double swap here. The positive and the negative ions swap. And notice, these are ionic compounds. So we have a double swap. So the positive and the negative ions swap partners. The way that we usually call this, we go, if the first species is AB, and you're adding CD to it, because those A's, B's, C's, and D's all represent the ions in the species and the compounds, you end up with a double swap. So you get AB plus BC. If you don't see that, if I put an A over the PB, wherever I find it, and a B over the NO3 wherever I find it, and a C over the Na wherever I find it, and a B over the Cl wherever I find it, you can see I have AB plus CD makes AD plus BC. Double swap. The third type of reaction, synthesis. Synthesis means to create something. We take two things, elements by themselves, and make a compound. Aluminums, 4 moles of aluminum and 3 moles of oxygen molecules makes 2 moles of aluminum oxide. Well, if we're going to follow the same rules and conventions that I've been using so far, we have A plus B makes AB. And if we go back and look at it again, every time on this example I find an H, I put an A over it, and I put a B over the O's, and then I trace down my arrows. I got A plus B makes AB. That's about all there is to figuring out when it's single replacement, double replacement, synthesis, or the last one, decomposition. Decompositions are the opposites of synthesis. Synthesis is to make something. Decomposition is to break something down. So in this case, we have the same type of scenario that we're going to look for code letters. We're going to put codes over the elements. If Ba gets an A wherever I see it, and CO3 gets a B everywhere I see it, well, that's, I guess, not a perfect example there. That's not a great one. Either way, we're breaking something down. We've got one thing that's becoming multiple things. I guess that's maybe a really, really easy way to look at the decomposition is you've got one compound becoming something plus another something. See, it's kind of working out in that way. One thing breaking down to make others. Typically, if we put the codes over them, they look like AB becoming A plus B. But as you can see in those examples, it's not exactly that cut and dry. So really what you want to look for is something creating two products, one reactant creating two products. So this is a short video, but at this point you should be able to at least have a foundation of how to put code letters over elements and polyatomic ions in a chemical equation to see if it's following the rules for synthesis, decomposition, single replacement, or double replacement. There's a lot of practice packet pages in here because some of them involve balancing and some of them involve coding them to the 4 different reaction types. There's also a small online Castle assignment for you to complete as well. So thanks for watching. See ya.